Logarithmic functions. Hey, this is an exponential function right here, and there is such thing as the inverse exponential function. And what inverse functions do is they switch the x and the y. Okay, so what we're going to do is we're going to switch the x and the y on this guy. We're going to put the x first, and we're going to say 2 raised to the y power. And you guys can see that there's a reflection right here. This curve right here copies the red curve. It actually reflects over a certain line, a particular line, known as x equals y or y equals x. So any inverse function would reflect over that line. Now this is right now not written in function notation. If I were to write that in function notation, it would look something like this, like f of x equals 2 to the x power. So how would I write this in function notation? I would write it like this with a log. What? Yep, with a log. So I'm going to call this the g function. This g function is the inverse of this f function, and as you can see, it reflects about the y equals x line. So I want to talk about that guy for a little bit. So let's get rid of these guys. We're going to talk about the log function. Like, what do log functions look like? Like, how do they change when we reflect them or shift them? Okay. Now I first need to make note of a very important point here. I want you to go away. The very important point is at 1. This point right here is very important because he stays there no matter what base we have for our log. What do you mean what base? You see this 2 right now? He is the base. I'm going to change that base. I'm going to say he's an A. And that A becomes a slider right now. And I want to show you guys what happens when we change it. Okay, what's happening to my curve? Whoa. There we go, I fixed it. The base can't be negative right here, so I'm making it go from 1 to 10. Here's my log. Notice that the point is always 1, 0. It's always 1, 0. Why is it always 1, 0? There's always a 1, 0 on log functions regardless of the base because, well, think about the exponential function 2 to the x power. Whoops, that's not right. 2 raised to the x. Okay, look at this function. See that point right here? The 0, 1? Remember I told you guys the x's and the y's switch for inverses? The x and the y switches for the inverse. And so this point always exists for an exponential function because anything raised to the 0 power equals 1. Yeah? Yeah? Okay. For the same reason, when you plug in a 1 to a log, you will always get 0. So you check this out. If log base 2 of 1 meant what power of 2 equals 1? Guys, what power of 2 equals 1? 0. It has to equal 0, and that's true for any base. I can put a different number here, like your mom, and I can say, what power of your mom will equal 1? And you'll be like, oh, that's 0. It doesn't matter what number goes right there. You will always have a 1, 0 point on your logarithmic graph. All right, so now I finished talking about the base. I want to show you guys what happens when I put a negative right here in front of the log. What do you guys think is going to happen when I put a negative right here in front of the log? Think about it. The negative would be the last thing that happens to the number. Like you plug a number into this, log base A of that number will give you something, and then you'll slap a negative onto it. So what's it going to change? It's going to change all the y values. See, check it out. Boom. All the y values changed. Okay? So it reflects over the horizontal axis, but it doesn't always reflect over the x-axis. It could reflect over different axes. And for that, I will show you this. I will show you an increase. If I add 2 to this, boom, what happened to my function? Yeah, look at my point. It changed to 0, 2. I mean 1, 0, or 1, 2. It was 1, 0. Now it's 1, 2. So if I put minus 2 here, what do you think is going to happen? Boom. Okay, so now I can show you guys some lots of shifts just by making a little slider right here and pressing play and letting it go up and down. You guys look at that? Ooh, look at that. It's going up and down. Oh, isn't that amazing? Oh, this is so great. I can watch this all day. Not really. Okay, so I'm going to make this back to 0. Okay, now we're back at where k equals 0. That was shifting up and down. What do you guys think it's going to do? It's going to do if I add a 2 inside with the x. Shift it to the left? Is that what happened? Did it shift it to the left too? What's this point right here? Ooh, look at that. It's at -1, 0. So it did shift to the left. So this is normally our h. You guys remember hk? H shifts the function horizontally. K shifts the function up and down. And so h would move the function back and forth. Look at him go. It's like he's dancing. Yeah, you want me to do them at the same time?
Yes.
Okay, first let me zoom out to show you. Look, it's just moving left and right. He's going back and forth. Okay, go back to home. Let's make them both move. Yeah, all right. This is exciting. Look at that. He's just going all over the place. All right, now, hey, let's change the base at the same time. Ooh, whoa. Now he's like, yo, what's up, guys? Watch.
And it rings at the corner.
Yo, what's up, guys?
What is this?
Hey, I put everything back because we had enough fun. If I were to flip this or reflect this, it still does that. But what happens when I move the K? When I shift it up and down? I just moved it up. Now K is 5.25. If I make it positive, what's it reflecting over? That's weird, huh? It's reflecting over the horizontal axis right here. And it's not flipping over the x-axis exactly. So what would happen if, let's put the K back to 0. What would happen if I put a negative next to the x? I'll change all my x values from positive to negative. Here, let's check it out. Let's see what we get. Do we get, oh yeah, look at that. See, I flipped them all over to this side. Yeah. Okay. All right, now one more thing we didn't put on here. There's actually a horizontal asymptote on here. That's why when I zoom all the way out, sometimes it automatically cuts off. You guys saw that earlier. There's a horizontal asymptote at x equals 0. You guys see that? At x equals 0. I'm going to make this a dotted line. So that's my, did I say horizontal asymptote? That's a vertical asymptote. Sorry, I used the wrong word right there. And the vertical asymptote, will the vertical asymptote change with the K or the H? Let's see. If I move the H, it'll move to the left and to the right. Shouldn't the asymptote be moving with it? Yes, it should. So let's make my vertical asymptote equal to the H. And now it should move with it. There it is. Look at it. It's just moving left and right. That's great. All right, that's all I got.